Okay, we are live. Hello all, hello world. This is day 200 of studying compilers every day until I land a compiler role. It is kind of crazy that it's been 200 days. So, yeah, I guess we're finally at this point. And also, once again, this is doubling as like a 5K sub thing. Thank you all so much for being a part of this. What even is the word to describe this? Journey, adventure, experience. This channel's history. Yeah, it's been an insane 200 days so far, and hopefully the next 200 or however long the series ends up being, or even just like the next eventual future where I continue streaming. Hopefully all of that is just as exciting as it has been up to this point. Last time we continued the big HIR rewrite slash, I guess, trimming. This time we're gonna take a break from that. I have some ideas on some stuff that I want to read through. Specifically, there's this paper which like catalogs a bunch of compiler optimizations. I've been meaning to read through it for a bit, but I never got a chance to. So I guess this wouldn't be a bad time to do that. At the same time, we're gonna try and make like a taxonomy of compiler optimizations. So that should be pretty cool. Hopefully it all goes well. So yeah, I also have a couple of other references that are kind of just at the ready. So yeah, let me pull up the paper. Let's see, where does this live? This one. The catalog of optimizing transformations. So this is like kind of the go-to, I guess, whatchamacallit, like the go-to catalog of all of the different optimizations that I guess are generally used at this point. There is some stuff that's like missing in here, because, well, this paper is from 1971, which is ancient, but yeah, it should be a good start. So I guess we could work through this. I haven't actually read it, but I have been told that it is a good resource. So yeah, we're gonna try to do a little bit of categorization and make a taxonomy. It'd be pretty cool if we could do that. Aside from that, there's also like the LLVM list of passes that I think might be interesting to look at. Obviously I've like looked at some of it, but I haven't looked very aggressively at it. And this also has some like very aggressively merged, I guess, passes. So like inst combine has like a bunch of different things. So yeah. Yeah. And then there's some other references. There's this little blog post that I found on Reddit, and it seemed interesting. So maybe we could look through this as well. And then of course, a little bit sillier, there's a Wikipedia page, a list of compiler optimizations. Yeah, there's like this whole pile that might be interesting to look through. I'm not sure how useful it is, but we will take a look at it. What's up, Xloppy and Crypt Incognito? I appreciate the support, y'all. I'm doing alright. Hopefully you're doing alright as well. I need to get dinner at some point, so I'm actually a little bit hungry, but I had a snack before this, so I think I am fine. Okay, let's get started on this. So I'm gonna be keeping like this. We're gonna be keeping notes on the side, just because I think it will be fun if we do that. So can we like dark reader this PDF? We can't. PDF dark reader Firefox. Let's see if this exists. Oh, I guess it does. Neat. We'll see if it works. People seem to like it. Okay. So if we go back here. Bruh. Okay. Let's open it again. Where did this go? Papers. Okay, that's really annoying. Okay, this plugin is useless. That's very unfortunate. Let's see. Is there anything here? Huh, okay. Well, that's very unfortunate. I'll figure out something in the future, but we will just have to we will just have to suffer from full blind on one half of the screen. So, yeah. What's up, Romy? Plugging my own packet viewer and traces and everything? Ooh. Yeah, IPv6, I guess. It is pretty obvious that, like, there's a good reason that it's not being really uptaken. It would have been smarter if they just, like, I don't know, like, stuck more numbers on instead of doing whatever they did, but who am I to judge? Okay, let's take a look at this. This font is very unfortunate, but I guess it makes sense. A result of the recent work. I fear this might not be recent anymore. This is 1970s. So it's not all inclusive. So this is just like a lot of the stuff that existed at the time. Yeah, so generally these are optimizing for execution speed. And like that makes reasonable sense. Optimization is a misnomer. Yeah, I guess that's fair. It doesn't necessarily like improve the program. I guess like this is why I kind of generally talk about things as like just transformations in a more broad sense. Yeah, I imagine it's not fun to work with, at least. It seems rough. Okay, let's see. Correctness. Yeah, correctness is important. Yeah, presumably we want our transformations to be correct and not like change the semantics of the code. Semantics? I guess dynamics. It should still do the same thing at the end. Okay, so now we get to the actual transforms. This is 30 pages, so this stream is either going to be really interesting to you or it's going to be really boring to you. So we got all the transformations here. So let's write to like, I don't know. Where do we even write this to? Windows. Let's go to like documents. Let's write it to like, I don't know. Forms MD or something. I don't know. What's up, Taran? Hair is fully dyed? No, it's actually like very much fading. If you remember like from some of the streams where it was like almost blue looking, that was like fresh dye. But yeah, this is like more pink, I think, if anything. So yeah. Yeah, okay. So yeah, this is like interesting as well because I skimmed this paper a little bit. It seems like it talks about like transforms in like the conventional middle-on sense that we know. So like, oh, we have this page up here actually. Let's just use that. Let's use this one. So like if we go to like if we look in like LLVM, we have like this whole pile of like transforms. These are like the traditional sense of like optimizations that I think of, but it also includes a lot of other things like it talks about things like linking here, for instance, which is kind of interesting to think about. And then like if we scroll down to the bottom, skipping a bunch of stuff, it talks about like this is talking about like storage mapping, so like specifically with memory and like caching. Like regalloc falls into a category for some reason, which is like kind of interesting. and then like shadow variables, whatever that is, so on and so forth. But like, there's all these various different things that generally we don't really, I guess it's really easy to forget about as like a literal optimization. So yeah, it's kind of interesting to think about. What's up, Izrith? Also, what's up, Max? Did you implement volatile? Not yet. It shouldn't be that hard. I just need to like parse it and like propagate the information forward, but like still. I probably need to build out like an attribute system before I can do that comfortably. Going down the Arch install today? Hell yeah. Yeah, it's a little bit hard to it's a little bit daunting the first time, but you'll get through it. The Arch wiki is pretty good, so yeah. Shadow variables. Oh, like literally shadowing? I guess that's like the PL sort of way to describe it. Where did this go? Like it talks about like parsing as an optimization, which I think is really interesting. Right, let's see what it says. Shadowing. Oh no, this is not shadowing. Not only variables are not only kept in the form specified by the program, but also in a form more appropriate for their use. COBOL, decimal, radix. Certain numbers are frequently used in arithmetic, and assuming binary arithmetic is faster, can be kept in binary. Wow. I don't really understand what's happening here. But yeah, okay. Let's go back to the top. Let's just like slowly work down this. I think it'll be interesting to try and categorize things, because it's really hard to find like a proper like compiler optimization taxonomy anywhere. So yeah, it's not like, it wasn't really talking about like shadowing, at least, which is interesting. What's up, Levon? Do you find Notion somewhat overcomplicated? I think it's fine. It does what I need it to. Very frequently also doesn't do what I want it to. But like it's fine. It gets the job done. I think in terms of having something that I can take notes on and then have them, surprisingly, like the one big thing that has been important for me is being able to like transfer that stuff to other devices. So like my other laptop, my phone, my iPad. It's just nice having it all in one centralized place, at least. And like it's nice to make like little trackers and stuff. I have this journal thing, and like that's pretty cool to have on there. And then like I like track my gym stuff now on there, and it's been passable. There are some gripes I have with it, but overall, like, I don't really think anything else does the job. Like Obsidian doesn't really transfer well to like mobile, for instance. And like obviously I'm not going to use Discord to like take notes. So like, yeah. Overall, I think it's like, bottom line, I think it's like fine, at least. Okay. Let's take a closer look. So procedure integration. So this looks like it's just talking about linking. Right. Oh my god. Okay, this PDF is poorly formatted, which is unfortunate. Subprograms and/or their prologues may be merged into their... Oh, is this talking about inlining, actually? Wait, what is this? Is this talking about just like generally like linking, or is this talking about like inlining? So closed linkage, this is just like, this just seems like a standard linking experience. Oh, wait, loader, that reminds me. I recently learned. Have you ever wondered why the linker is LD? It's because it's short for load. Because like another like synonym for like linker is like loader, because you're like loading the program. So now you know, LD, that's where that comes from. So system loader, that should prompt that. Okay. Yeah, so like standard issues with linking. Yeah, we have to like save and restore registers. Yeah, something about allocation. Interesting. Da-da-da. Okay. Okay, so comparing this with open linkage. So is not a linkage at all. That's very helpful. Okay, so this is just inlining to my understanding. Okay. So we will have a uncategorized section. We will make a taxonomy up here. So this we will call just like inlining. I guess everything's kind of inlining if you think about it. Or like a lot of optimizations are just inlining in disguise. Like constant propagation is inlining in a sense. So we'll just call this like function inlining. We'll figure out where to group it once a group shows up. Okay. So this is just talking about like, I guess procedure integration necessarily means like inlining, the more I think about it. So like it kind of makes sense. Trying to make sense of Unix shortening is something I gave up on long ago. That's so real, yeah. Why is CC compile, or like the compiler? Yeah, exactly. Like it's just a little difficult to figure out what's happening. Okay, so inlining. If you're not familiar with what's happening here, or if you want like a visual example, actually let's make a tmux window. So let's put what did I call this again? Taxonomy or transforms? Okay. So we can just create a window. Yeah. So the example here, if we have like int foo, or actually code temp. Let's just make a C file here. So we have int foo, and then we have like return like bar of 3 plus 1, for instance, or we can just do bar plus 1 here, and then we declare like int bar up here, which is like return 1 plus 1. So what inlining is you take this body, you just paste it in here. That's all inlining is. So yeah, that's the short explanation of what's happening here. This is also useful if you have like a function body that you want to like paste in. Okay. So we don't have any like calling convention stuff to deal with, and this also lets, I guess, optimizations pass the function barrier. That makes a lot of sense. The convo I had with a friend about how meaningless file extensions are, yeah, like at some point I kind of just like gave up on trying to like make file extensions and just threw whatever at the wall. Like the first time I saw a file without an extension, I was like, what is this? And it was kind of funny. I don't know. Text files, like, I don't understand why like text files exist. I guess it's just like, it's better to like standardize it in some way, but like maybe it encodes other information. I don't know. Okay, so drawbacks to inlining. Programs get big, that makes sense. If you copy a 1000 line function in like 10 different places, your code 10x's in size. So that's probably bad. Irreducible subprogram. What? Oh, like things with like static variables, or like function local static variables. Guess that makes sense. Wonder what was the original purpose of file extensions? I mean, surely it's just for like human readability, right? Like, in that case, that also explains why text exists. Okay, and then high-level version of the program being called must be available. I don't get that. Is this just saying like we have to be able to like we have to have the function being inlined? I guess that's probably what it's saying. Okay. And then what is semi-open? Wait, what? Wait, this is insane. Wait, what is happening here? S is compiled with its caller C. They become part of the same object module. Wait, what? So is this just like a private function? Is that what's happening? Maybe I'm just like completely misreading this. For the OS. Yeah, that might be another reason actually. That makes a lot of sense. Oh, I see what's happening. So like if you have like if we go back to like this example here, instead of like pasting the body bar in here, you would probably like just jump into the function somewhere instead of like dealing with the calling convention overhead. I guess that kind of makes sense. Yeah, this seems like a mess. And then semi-closed is like, huh. Yeah, I don't care enough about this, to be honest. But okay, we've added inlining to the list. I guess that makes a lot of sense. Yeah, okay. Oh man, we're on page 6. Okay, this might be a bit of a dull stream actually. Okay, so subprogram. Okay, this talks about COBOL, so I don't want to read this actually. Let's scroll past that a little bit. Anything interesting here? Not really. Okay. All right, we're on loopland. So there's a lot of loop transformations that exist, and we can do a lot of different things with it. So, we could probably make like a loop group somewhere. So, loop. Let's start with loop unrolling. So, I believe there's also, I know loop peeling also exists, which is like less unrolling. So we'll add that to the list as well. So what happens in this, so we have like for int I equals 0, I less than 5, I plus plus, and we call bar. So given this, and then like return 0. So what loop peeling is we would basically take one iteration off of this. So we'd basically do that. And then what unrolling is we would just unroll it completely. So we'd just do that pretty much. So one of the optimization steps the compiler takes is copy and pasting short functions. Yeah, I think you might just be describing like a basic inlining pass, where you just like inline a bunch of functions. But then you have to like evaluate whether it's better or not, because Um, there are like concerns with like code size, for instance. Okay. Loop can be unrolled. So there, yeah, it can also be partially unrolled, which I believe is peel. Actually, let's look this up. Loop. Okay, I guess. Yeah, I guess this falls under loop unrolling. So maybe it's a little bit insane to split it up. But still, loop peeling, just in case. Yeah, and you do have to modify it. That is correct. Okay, so this example, oh man. So this iterates 100 times, and it does that. So unroll by 2. I see, so we like unroll one layer of it. So we skip by 2s. Okay. Yeah, so we do execute less instructions because we do less like condition checks. And then this also makes it easier to like parallelize things as well. This could be a fun thing to write a optimization for, actually. Okay, the next thing here is loop fusion / jamming. Whatever that means. So two loops are merged. So like, yeah, this example, let's just rewrite it in C. So if we have this, and then we have like, and we have that. The way that it would, I guess the way you'd fuse the loops is you would just move this into here, and then you delete this, pretty much. Yeah, okay. And that's nice because then you iterate through the loops less, and that's a good thing. Yeah, and then if the computations don't depend on each other, then this is safe. Yeah, there's a lot of interesting code analyses that go into this, and I think that'll be really fun for me to implement at some point. Actually, I'm really excited to give that a try. Yeah. Yeah. So they must both be executed, and they must not depend on each other. And they must also be executed the same number of times. Oh, interesting. Okay, that makes sense. Example, so matrix multiplies unrolled and then jammed. Okay. So oh man, this is so ugly. Okay, this is just basic matrix multiplication. Does that mean you have to check if the condition gets affected by the loop body? I believe so, yes. That's just like the big like data dependence analysis pile. I haven't learned a lot about it, but I know that like it exists. I imagine LLVM has like something for this as well, for instance. I think it's this. Is there like dependence analysis? Is this, yeah. I think. Are you in college? Yes, I'm finishing up my master's right now. And by finishing up, I mean I have like a year left. Okay, so this outer loop is unrolled by 2. I see, and then these inner loops are jammed because we've just copy pasted it. So, yeah, okay, that makes sense. And then this can this creates opportunities for like auto vectorization. which we should probably put somewhere here. So vector instructions, they do like multiple things at once. That could be useful. Good luck, keep up the grind. Thank you, I appreciate it a lot. Okay, and then we do more unrolling. Oh my. Oh boy. Yeah, I don't want to read this example for too much longer. Okay, unswitching. So this is the opposite of jamming. So we are splitting a loop, I believe. I think there's a more formal name. Right? What is loop rotation? Wait, what is this? Oh, is that it? Ah, I see. So like do while. That makes sense. And that generates code cleaner, I imagine. You Chicago? Hell yeah. Like, wrong school, but also hell yeah. Quote unquote first year? Damn, okay, wait, you're kinda cracked then, Loki. Strength reduction, we'll worry about that later. Lickum, we'll worry about later. Okay, so then this doesn't wait, this didn't answer my question. I swear there has to be a better name for it than just, I guess it is just jam. People really like jam. We'll call it loop jamming. And then we'll do loop unswitching. So we're breaking a loop containing a loop independent test into two loops. And then the test selects which of the loops to execute. Oh, I see. Okay, this makes sense. So if we go here again in this example, and this has to be independent of the loop. So like int foo bar equals like 5 or something. And then inside here we want like if foo bar is greater than 10, then we do bar, else we do baz. So what unswitching would do is it would pull this if else out, and then it would kind of duplicate this loop for the logic. So let's just pull this out like that, and then let's move this into here, and then this goes up here, and then we can do the same here, but instead of bar we put baz in. So this is kind of what's happening here. And that's nice because then you do the if check only once, and that's faster, presumably. So that makes sense. That's pretty cool. We don't need peeling. Okay. Used to study Mekhi. Mekhi? Damn. I guess CE is like an interesting in-between. I don't know. I imagine CE is also like really difficult. I do not know a lot about like architecture, which is really funny given like the stuff that I've been wrangling with, but yeah, CE has always like been really cool to me. Okay. Yeah, so this does have the downside of requiring more space because now we have two loops instead of one loop. It is not clear how frequently unswitchable loops appear, and therefore how important this transform is. That's really funny. More electronics? Wow. Really, I don't know. Like, all of my friends in like CE, they're all like, they're all doing a lot of like hardware design slash like verification stuff. Like they're in they're in like ASIC slash FPGA hell. Don't ask me to explain what those are if you don't know. You should Google it instead. I would not be able to give a good explanation. Okay. We have finally decided to define basic block here. Yeah, we love FPGAs. That is the one that I can like explain with like one sentence, but if you ask me to elaborate, I would not be able to, unfortunately. Optional class on advanced FPGA, damn. Yeah, that seems fun. I wish I had taken more like CE or like hardware-y classes, but well, I'm kind of running out of time to do that, for better or for worse. So, unfortunate. Okay, let me lock in again for a second. What is happening here in this little blurb? I imagine this is like external to all the loop stuff. I think it's what's happening here. So then, machine independent optimization, transform. A distinction is made between those involving sub-expressions in the same basic block and those involving sub-expressions in different basic blocks. Okay. That makes sense. So that is one thing we could split by. So like local slash like control flow graph level optimizations, I guess. That could be interesting. So maybe we could do like local optimizations and then control flow graph optimizations or transforms. Yeah. Oh, that's not the right key. Yeah, so we can do that. Maybe we'll do like global. I don't know. I don't know how global will look, but we can put a loop. We can put a loop category here. We'll start with that, I guess. That seems good. I like how that looks. It's not important if you're already stuck on LLVM. I see. I guess that makes sense. It is crazy how like hardware kind of like, or every single level of abstraction, like it just, I don't know, it like assumes the user is an idiot, right? Like the whole idea of like lazy loading or like speculative execution or like making all these like aggressive assumptions slash optimizations about a program. It's all like really funny to me. I don't know. Like, yeah, speculative execution in particular is just crazy. Like, wow. I don't know. I wish I had just taken more hardware classes. Oh my god. I've run out of time, but like, fuck. It would have been so cool. Yeah, the user is in fact pretty dumb. So like it makes sense, but at the same time it's like, I don't know. It's just so cool. Yeah. Can we add a function to check if there's a linked list written by someone and output an error saying don't do this? That would be a funny like, that'd be a really funny like linter check actually. I'm not sure how I would go about doing that, but it would be funny at least. Yeah, hardware is just like, oh my god, it's so cool. It's so hard to like get the resources to like learn hardware stuff outside of classes as well. Cause like CS you can definitely like self-study because like the only resource you need is like a computer and like an internet connection. Like hardware, like, well, you need hardware, and that's a little bit harder to work on without like proper funding. Looking at how DDR RAM works. How does DDR RAM work? Oh. There's a tech quickie video. That's really funny. Let's see. What's a good page to look at? Surely Wikipedia will be fine. Yeah, this is black magic to me. The capacitor issue, is this the whole like we are running out of space thing, or like we're running out of we're running out of temperature overhead? Yeah, this is that page did not help me. Ah, full blind. Something about memory cells. Something about a storage capacitor and transistor. Wow. Yeah, like this stuff is so cool. I wish I had taken the classes to learn about this. I guess I still could take the 200 level intro to CE class, but like, you know, we're like out of time, you know, like it's very unfortunate. Whole optimization against capacitor charge. That makes sense, yeah. That's so cool. Oh my god. Okay. Let's look closer at this. So, basic block, it's a linear sequence of instructions with one entry point, and then an exit point. So like, that makes sense. Like, if you're not familiar with a basic block, it's just a straight line sequence of instructions that has no like branching. Yeah, I forgot about like the whole quantum tunneling thing. I thought it was literally just like the big problem was like heat. Like we have run out of ways to cool things that small. RAM has to let you work another bank if a specific bank is charging. Yeah, holy. Yeah, I think like heat was like the canonical explanation for like why we started to parallelize things, at least given in our like intro classes. Okay. Internal data dependency. Okay, so like that makes a lot of sense. Algorithm exists for finding the best assignment of n registers. Okay, so like that is just like regalloc, I guess. Or local register allocation. The literature, and it cites like five different papers / books. Wow. Okay, global optimization. So this is mostly focused on like the global stuff, which makes sense. Or I guess CFG / global. I guess we could do it like that. CPU gates are mostly limited by quantum. Oh yeah. Yeah, I guess like I don't know, it's just this is like way beyond my pay grade, so I don't want to like say too much, but all I will say is that it's cool as shit. Also, I'm fiddling with 2 Chipotle forks, because when I got Chipotle yesterday, they gave me 3 forks for my burrito, which I'm not going to complain about, because I always get 2, but like, we got all the forks in the world. Okay, so we have control flow graphs. So, redundant sub-expression elimination. I've heard common sub-expression elimination more frequently. Is that what exists here? Okay. Okay, I guess that doesn't really help me here. That's fine. Okay. Wait a second. Wait, is this just global value numbering? Is that what this is? Is that Oh, it's distinct. Interesting. Wow. Okay, wait. So this is just like literally replacing the sub-expression. I see. Okay. That makes sense. Okay, so... Oh man, we gotta scroll up again. So in these examples, okay, so we have those sub-expressions. Yeah, that makes sense. So it does have a subsequent use. I ordered one burrito on DoorDash and somehow end up with 3. I mean, we take those. Like, extra food's always nice to have nowadays. Undergrad research and modeling predictions for particle collisions. Damn, that's some crazy shit. Yeah, I don't know. HPC stuff is also just so cool. Everything is so cool. There's so much cool stuff in computer science. It's just like, unfortunately, I have decided to focus on this one cool thing, and it really sucks because now there's all these other cool things that I just don't have the time to really explore properly. Like, damn. Yeah, I imagine you also have a lot of qualms with the compiler then, because yeah, we really like to make aggressive optimizations that maybe break correctness with floating point. Yeah, physics and CS seems like an interesting crossover. There's a lot of really cool crossover sort of land. I imagine like there's a lot of like computation stuff in biology that's also pretty cool. Okay, let's put this here. We'll just do that. Okay. So it has another use because we use it again. Like, we assign to A, and like we need to use A, obviously. Okay, so in both examples, correct though not necessarily identical values are available on every path. Okay. So it's redundant because on its first, or I guess like, in every path that includes the nodes before, I guess we could use like dominator tree like terminology here, but yeah, the value computed in 1 and 2 here on the left example or 1 in the right example will always be the same in, I guess, the reassignment. Okay, so that makes sense. What else can we do? What else can we learn here? Was formally identical. Formal identities. Ah, this is global value numbering. Wait, okay. Yeah, I was never good at optics. I was actually just never good at physics, to be honest. I was quite bad at physics now that I think about it. So, I mean, that is very unfortunate. Okay. So C times B is not formally identical with A times B, but computes the same value. I see. Okay, so we could throw global value numbering here. It seems like it's distinct in some capacity, or at least nowadays we treat it distinctly. Yeah. Best at physics? Really? I guess fair enough. I can't really I can't really like make any assumptions about that. How do you deal with the whole virtual memory thing? What do you mean? In what context, at least? Oh no, it's fine. Like it's just a good time. I guess I'm just surprised given like the major you chose. Entangled photons. Yeah, that's outside of my that's outside of my pay grade. Like how you compile programs. We don't really worry about it, to be honest. Like, we worry about it insofar as like we want things to like ideally live in the same page, or like we want things to like, I guess, cache neatly, but like beyond that point I don't think there's a lot really. Like it's more something that like OS worries about for the most part. I'm very happy that I don't have to worry about it, actually. It would be it would be quite miserable if I did. Okay. Let's see. Okay, so we found global value numbering. Okay, so this finds like functionally equivalent subexpressions. What's up, Aiden? Do you want to know something quite funny? What's up? Yeah, okay. So it is a redundant calculation. So what is the other one called, at least? Is there, like... I did all of assignment 4 because Buffon was busy, but he got chosen to panel and I can't because I already went. So, wait, that's insane. Wait, that's gonna be a really funny presentation. Oh man, do I show up? Wait, I kind of want to show up now. That'd be so funny. You know what? Yeah. Fuck it, I'll show up tomorrow. That'll be funny. Yeah, the whole like code manager thing is like kind of fun until like it's you're just like really tired at like 5 p.m. and you don't want to ask questions and you just want to go back to your room. But like it's like fine. Free points are free points. Okay, so I guess these are like kind of two separate things, I guess. Okay. So this is good because we do less instructions. Okay, but it pressures registers more. Sure, sure. Yeah, I mean like, it is like good practice for like CodeBox anyway, right? Because like eventually you'll be at a point in some company where you have to like, you gotta like review someone else's code, and like, generally speaking, I think the code reviewer is considered as responsible for the code as like the person who is presenting is. So like it's probably good to like be good at like picking someone's code apart, even if it like feels like shit. Stats has always been one of my least favorite fields of math. Wait, that's a crazy sentence actually. Wait. What's up, Panda? Are you in college right now, or did you graduate? I'm currently in college. I'm finishing up my master's. At 60s on both finals? Aw. I mean, surely there's a curve, right? Hopefully the curve will do you well. Okay, so let's make a category here, like redundancy elimination. information. I don't know. We'll categorize that later. Okay. Code motion. What's up, Nourish? Yep, it is. It is in fact day 200. Is this IR stuff? What did I do? What the? Huh? There's a highlighter? What? Okay, wait. Can I like? Okay. PMO. Yeah. This is like I'm reading through this neat little paper on like. It's supposedly like, it's a quote-unquote catalog of optimizing transformations. So it's just like a bunch of optimizations. I've wanted to make a taxonomy at some point, and I just never got around to it. So I was like, I'm just gonna do this for day 200. I thought about like rewriting NeoVim config to use like the native plugin manager. And then I looked at the state of it, and I was like, maybe not. So yeah, we're still using lazy.nvim. But yeah, we're gonna make a big taxonomy. It's gonna be fun. Value range analysis. Yeah, you're gonna have fun with the IR. You actually have a control flow graph to play around with. It will be a little bit annoying to write a lot of analyses, but like, you just gotta like read a bunch of papers and like implement a bunch of stuff. And like, it'll be fine. Also been working on optimizations. Ooh, that seems cool. Congrats on day 200. Thank you. Okay. It will seem that code. Okay, so how do we? Presumably, we want to group code motion and redundant sub-expression elimination somehow. I guess maybe not. I guess it's kind of a different thing. We could kind of group all of this under like reassociating, maybe. I don't know. %. Yeah, I think it's pretty doable, to be honest. Like anyone can do it. You just gotta like. It is just like a question of hours. And like, how much time you really want to spend like reading a paper on like generating a dominator tree. 5% for 2 thumbs up. That's fair, actually. The double thumbs up always feels really nice. We love guys there. Okay. Sub-expression can be moved. The value available to its use is not changed by the move. Okay, sure. So if it doesn't change dependencies, that makes sense. So this and wait, what? Wait. Oh, we hoist it up here. I see. Okay. We hoist it up there and then we reassign it here, I guess. That makes sense. Does that make sense? Wait. It was assumed that neither A nor B were changed, but everything else here. Okay, sure. Dominator trees are kind of the GOAT? Yes, they very much are. I think if you have like, there's like a couple of big analyses. We can look at like what LLVM has. So this is under analyses. Yeah, so dominator trees are pretty important. I think loop detection is probably good as well, because that unlocks a lot of the loop optimizations as well. Like if you can just like unroll something and then like fold everything in it away, it's really, really good. Yeah, I think those are probably the big two, to be honest. The dominator tree algorithm is not bad. I did it at one point. I have a paper I can like send. Dependence analysis is also pretty important as well. Yeah, I think that's probably the big three to look at. And then like if you do like SSA construction, that makes some of this a little bit easier. But yeah. Okay. Sure. So it's invariant with respect to the loop. Overflow, sure. Wow, okay. This is very messy. And then there's also like, I've heard like loop invariant code motion used before as well in some, oh my god, this goes on for a while. Okay, we don't care about too much about the semantics here. Damn. Yeah. Yeah, so we just make it execute less, which is good, I guess, generally. An improvement may not always result. This is the source of much evil. Okay, and that's like an example, sure, okay. I've been staring at this for like an hour now, so we're gonna like speed along a little bit, just so we can actually get done, but yeah. That's a funny looking eye. Hoisting, okay, that is loop invariant code motion. I believe that is what it's referred to as. Wow, okay, wait. That's crazy. So this is how we're grouping it, I guess. That makes sense. Wait, we could just go off of like Wikipedia's already done the work for me pretty much, is what I'm seeing. Deforestation, what are we calling it? Where did this go? Is there like a hoisting page somewhere? Code motion. Surely it's somewhere here. Yeah, okay. Loop invariant code to position outside the loop. So I guess we could... Yeah, it's really hard to categorize this stuff. I can see why people haven't done this. This makes a lot of sense. Yeah, so we can also throw that as like a sub thing. Oh, there is an article in it. Yeah, okay, so it lives here. Okay. Huh. Curious. Okay. So then, where did this get grouped in? It's just not here? Okay, great. Anyways. Yeah, so it saves instruction space. Wait, what? How does IntelliSense work? Is it just taking stack analysis? Yeah, pretty much. I guess like I don't want to call it IntelliSense because like IntelliSense is like a very specific instance of static analysis, but like yeah. It is just like taking stack analysis or doing static analysis, finding like errors and then like giving them to the user. Hungarian alphabet. Ah, that's that's a lot more characters. a lot more combinations of characters that I'm used to. Let's see. Okay, so this like composes a bunch of, I believe this just composes a bunch of transforms. Is that what's happening here? Yeah, okay, that makes, I guess that makes sense. Okay. Yeah, IntelliSense is quite dumb, actually. Okay. Oh man, this is hard. This is very hard to categorize things. Okay. Let's put constant folding here. Let's actually just move these out of here again. Okay. Constant folding. I've heard constant propagation. I've not heard subsumption before. I guess that makes sense though. Yeah, this is straightforward. Have you ever tried Rust? Yes. I think that's where I've heard like, I think I heard subsumption in that context for some reason. I don't remember why. But yeah. Yeah, so this is just replacing uses of a variable that's assigned with a constant with just the constant. It's like here we just replace a with 1 and we replace b with 5, and then we also just pre-compute that. I think constant folding and constant propagation is distinct as well, right? Oh, interesting. There's another thing here. Has many obvious advantages and no disadvantages. Okay, yeah. That makes a lot of sense. Is there a thing here? Constant folding. Okay, so they are distinct. What is this? SCCP. E. Wow. Okay. Okay. So okay, so constant propagation is distinct from constant folding, it looks like. Or at least I should think of them distinctly. I know I'm like staring at Wikipedia, but like I've always understood them as distinct. The reason why I don't have a constant folding, or I have constant folding, I think I have both actually, to be honest. I might not do constant folding yet. I don't remember. I think I do both. But yeah, they seem pretty distinct to me. Okay. Dead code elimination. So this is like its own little category. The whole wiki section on floating point arithmetic consistency is very important. Yeah, I mean, floating point is just a giant mess. It's very unfortunate. Yeah, okay. Yeah, so the for branch we never execute, so we can nuke that. That makes sense. I don't think there are disadvantages to dead code elimination. I actually don't know. There shouldn't be. I guess like this is where we get into like really strange like time travel optimization land. do warn the user, yeah, that I feel like that's probably safe to do at least. Or like if you've like used an editor where like dead code gets like grayed out, that's like probably the cleanest way to do it. Okay, strength reduction. This I have heard about. I've never actually like learned what it is, so this will be interesting. Replaces computations. Wait, what? Replaces certain computations. How is this sentence grouped? Certain computations using recursively defined variables, or certain computations using recursively defined variables? Generalization of a relatively common optimization, replacement of subscript involving do loop induction variable. I feel like, wait, I feel like this is like, yeah, so this is a generalization of that. So if we look here, there's like, oh wait, real quick, fusion / jamming, fission / unswitching. Yeah, okay. Oh wait, no, these are distinct. Wait. Okay, we should add this here. Aye. Oh man, there's so much loop stuff. Wow. That's all so cool. What was I looking at again? Induction variable? Okay, yeah. Code above could be rewritten as this. Oh, I see. Okay. That makes sense. Okay. Oh man, okay. Replacement of subscript calculations involving the do loop induction variable. So what is happening here? By index register increments. Okay. So I see. So we're right, so this is like the example that we just looked at. So instead of just computing multiply by 5, we are replacing it with repeated addition because it's cheaper to add. But like, is it really if we're using LEA to do all the work for us? Anyway. Okay, what is happening here? More general form of strength reduction. So then, wait, what? Okay, so they are recursively defined. Wow, this is confusing me. This doesn't make sense to me. Okay, so we use faster computations. Oh. Linear function test replacement. What? What? Okay. Okay. I might have to look at the Wikipedia page for strength reduction. This is not making sense to me. This is not very taxonomy, I'm afraid. What? Wait, what is happening? Okay, so we care about loop invariants and we care about induction variables. So I guess we shouldn't like split it out because this necessarily looks at just those for the most part. Okay, so the induction variable changes by the loop, and then loop invariants are constant within the loop but change outside. Most expensive by a large margin is division. Yeah, I remember like dealing with this. Division was like miserable. Division really sucks. Multiplication you can like kind of get away with cheating around, but like I don't think there's a great way to get around division, unfortunately. Other than like left shift or right shift. Okay. So what's happening here? So the invariant here is C, and the induction variable is I. Huh? Oh, I see. Okay. Does this make sense to me? Okay, so we set it to like the first value. And then I see. So then the change in this is necessarily plus C. Okay, that makes sense. Yeah, okay. So then we delete the dependence on like the induction variable pretty much as well. Why is it called strength reduction? Oh, okay. Yeah, okay, that makes a mess. Okay, and then there's like this stuff as well. Hacker's Delight? Okay, that's a book. Okay, never mind. I don't care anymore. I still care, but like, I was expecting it to be something more exciting. Fast inverse square root, my beloved. It's like, this is insane. Multiply by a specific giant constant. Wow. Wow, that's crazy. Okay, so there are like, it seems like there's a couple main categories for strength reduction. Is there a better way that we can categorize this? Loop strength reduction. Ah, that's what it is. Or I guess this is kind of where it exists, at least. Huh, okay. We can do that and then like loop strength reduction. I feel like it makes sense to separate them, at least in my head. Make my pizza for breakfast. Damn. Well, thanks for stopping by, and hopefully, school plus work go well and your food is good. Yep. You take care as well. So we figured out what strength reduction is. Great. Okay, linear function test replacement. What is this? Okay, yeah. So like this is, that makes sense. A test on T. I see. Okay. I guess this is kind of a thing. Huh. Oh, I'm like, wow. Balance check elimination, my beloved. Wait, I love this. Deforestation, what is... Okay, anyway, oh, that's not what I wanted to do. Okay, we figured it out again. I feel like this is kind of... I feel like we can kind of jam this into something else, though. Yeah, it looks like people don't really like look at this one, it seems like. Huh. Huh. Okay. Well, this has become very murky all of a sudden. I appear to be struggling. Okay. We'll just... I guess this makes sense why we do this, because then we can get rid of the dependence on... We can just get rid of I altogether, I guess. Or at least the use of it. I'm not gonna add this. This feels very niche. Okay, carries. Subscript calculation does not need to be reinitialized. Okay. Okay, so this is all like machine independent, and then we have like the machine dependent pile. Oh man. I guess the machine dependent stuff is less interesting. That kind of fits in like the back end. Okay, so then, so what is happening here? What's up, full primes? I wonder if people tried to frame compiling as a process that can utilize category theory. I mean, surely that's something that's been attempted. I'd be very surprised if not, at least. Okay, so what is happening here? What? Okay, so we just initialize to zeros? Wait, what? Wait, what is happening here? Subscript calculation does not need to be reinitialized. Huh? I'm so confused by it. I'm so confused by what's happening here, at least. Is there like a Wikipedia page? No? Okay, well, that's unfortunate. Yeah, okay. Let's look at this pile now. So this will be like the backend pile. So we have like scheduling. I actually never learned properly how scheduling worked. Something about pipelining, that makes sense. So then the divider takes 12 cycles, recycle outer is pipeline, and start a new add on every cycle. Okay, that makes sense. So why is this faster? This is what, 3, 6, 9, and then like 10 plus 12. Oh wait, I see. Pipelined, okay. So this alone takes 3. Pipelining this is, so that's like 4 total? Alright, no, this has a dependency. So this waits for that. So this is 6. This has dependency as well, so that's 9. This is 1, so 10. This is 12. So this is what? 22, and then 1 for 23. So then what happens here? Wait, what? Ah, I see. We can start every cycle. Okay. So we start the long one first. And then these all run. So these take, this is what? 6 cycles here. So that goes to 9 and 10. And then we're waiting for this. So that's how we get to 13. I guess that makes sense. What's up, Ted? What is a compiler? It's a program that translates between programming languages. So like, a lot of compilers translate from the C programming language down to some variant of assembly language. Let me fix my camera. Yeah, the compiler that I'm building right now also translates C to x86 64 assembly. Yeah, that's just like one example. You can kind of do it with any language if you can translate it. Okay. Parsing. Why is parsing here? Yeah, I mean this doesn't feel like an optimization to me. I don't know. I'm not gonna write this down. Cause like, I don't know, like this is necessarily like an association sort of deal. No worries. Let me know if you want me to like explain anything. Yeah. I appreciate the compliment lots. Um. Okay, let's do register allocation. Store. Okay, we're getting to the point where like these are less optimization-y. Yeah. Rematerialization was interesting. I'm definitely throwing this in here. Yeah, because a lot of optimizations happen in register allocation, so I'm not gonna do a lot about this. Okay, storage mapping. Okay, so like, what do we even call this? I guess like space stash cache? Aye. Optimizations, I guess? I don't know. Storage mapping. That doesn't help me. Okay, that's fine. For computers with paging. It's funny that we have to specify that. How times have changed. What were you doing with Carrie? I can't lie, I didn't understand what was happening. Yeah, yeah. I guess like we're just... I guess like we're carrying the address? Like this feels like... I don't know, this doesn't feel really... I feel like surely this is like bundled into something that we've already covered at least. Unless I don't know, I just don't really see how it's distinct from like, I guess like some sort of like code motion, I guess, plus strength reduction. I don't know. Or what is being carried here at least? Yeah, anyway. Okay, storage mapping, I guess we've kind of put here. We'll just call it as it was explained. Shadow variables. I do not understand what is happening here. Anchor pointing. Huh? Minimizes the number of logical tests performed before a fall through occurs. Okay, so that's just like, sure, that makes sense. Special case code generation. Okay, this definitely just fits with like people optimization. So that's like local optimizations. Oh man. Wow. I recognize some of these names from textbooks and papers. Wow. Okay, so how the hell do we even begin categorizing this? Is there anything like particularly interesting in like this post as well that we could look at? Hopefully there's something. Hmm. Doo-doo-doo. Okay, I guess this is written for a less compiler focused audience, obviously, which I guess makes a lot of sense, but yeah. Hmm. Okay. I guess this doesn't seem very useful, actually. Inlining. Carrier requires modulo ops. I see. Yeah, it's like, I don't know. I think the way that it was referring to carry was less in terms of the modulo operation and more in terms of like, I guess just retaining a value instead of like, I guess like redeclaring it in some way. Which I guess like, it makes sense, but like, that feels kind of like in the spirit of like code motion. So I mean like, Okay, strength reduction. Wait, this is good. This is useful. Yeah, okay. Loop invariant code motion. That falls under... Oh, I guess that makes sense, yeah. 4. Okay. I can see where it comes from, but I don't know. Okay, that makes sense, I guess. Okay, more of this stuff. Wow. Max iterations is 100. That's crazy. Scalar evolution. What the hell? Wait, what? Wait. Scalar evolution. Wait. Huh, okay. That's interesting. Anywho. Dead code elimination. We love this. Yeah, that's fine. Okay. So this, I guess, just kind of goes over some of the stuff. Pull down an old book on my shelf. I mean, it's always nice to have, like, it's nice to have the old books around. I think it's just, like, interesting as, like, a history piece in some sense. Like, I remember, like, back when I watched, like, Daniel Naroditsky, rest in peace, and, like, his chess content, I really liked the way he kind of, like, beyond just, like, being knowledgeable about the game, he also, like, sprinkled in a lot of history, and I think that just, like, added a depth of, like, a layer of richness that I think I really enjoy, at least in like education. So I think like that sort of thing in terms of like is probably something we also should try to preserve in computer science in some capacity. I think like there's very little like we teach all these like all this like theory, but like we don't really teach a lot about like I guess the evolution of the theory over time. And I just kind of wish that like computer science departments did more of that. I think that's just like really cool stuff, to be honest, personally. Okay. Yeah, this is hard to categorize actually. Maybe we should just categorize LLVM passes instead. That might be easier. Wow. There's like a lot of crazy stuff here. Tail call elimination. Like, whoa. I guess like this all is like very theory or like group sort of. Okay. So is there anything here in this list that we can, or let's look at this list first. Automatic parallelization. Vector? Okay, yeah. I guess that is a special case of it. Okay, that makes sense. So let's... Okay, so this is the whole pile from... What's it called? The paper. Catalog of optimizing transformations. So that's where that's from. So now, let's add more stuff to this. We have a MISC section for stuff that I've decided to add in. Okay, so we want, let's see, automatic parallelization is rounding. In what sense, at least? Okay, what is happening here? Dynamic recompilation. Oh wow. I guess that makes sense. What is different between this and like PGO? Okay, this doesn't really help, I think, actually. We could definitely throw PGO in here though, I think. Pogo. I've never heard that. Is PGO in here? Yeah, okay. So we should definitely PGO. Okay. Okay, what is available expressions? I feel like I've heard of this before in some capacity. What is this? Okay, so it is a... Okay, so it is like data flow analysis, I guess. Okay, so I'm gonna throw this... I'm not gonna put this in the category. Okay, bounds check elimination. That is interesting to me. I think that's pretty obvious in some capacity. What is this? Rounding is choosing halfway point between two adjacent values. I see, yeah. Like rounding in math. I guess that makes sense, but it's like it is cool. It is definitely cool. I imagine it's like it's difficult to do quickly. At least. I'm kind of curious how that's done, but that's out of scope for a little bit, I'm afraid. What the hell is happening here? Okay. Code motion we have. Common substretch, blah, blah, blah. CSE we've done. Yeah, we're looking at optimizations. We've exhausted this paper. We're looking at Wikipedia now because there's a lot of interesting stuff. Yeah, okay. So we could do like, compile time evaluation, I guess we could call it. Compile time evaluation. We can, the idea here is hopefully we can start creating logical groupings for things. Right now we can definitely throw all the loop stuff into one little pile. And then like, there is like, there's like these constant folding things. We can kind of bucket them under like, I guess compiler evaluation maybe. There's some crazy stuff here. What you're doing? Right now I'm trying to figure out if there's like some sort of taxonomy of like compiler optimizations or like code transformations I can make. It should be, it's supposed to be a fun time, but I'm starting to realize it's a little bit difficult. Constant folding, yeah, we've done that. Okay, copy elision, copy propagation. We have not looked at those yet. Okay, copy elision, MLR dialects. Oh man, that's scary. And then copy propagation. Okay, that makes sense. Okay, yeah, so that makes sense. Okay, data flow analysis, dead store. What is happening here? Oh, I see. We do dead code elimination. I guess that's the optimization attached to it. That makes sense. Deforestation. Interesting. Escape analysis. What are we doing? Interesting. Okay. Do you think it's illegal to venture into compilers and interpreters using a dynamic language? It's probably fine. As long as you're comfortable with the language and it has like good enough tools to like parse things, I think you will be fine. I don't really think the language matters that much, to be honest. There might be times that like you necessarily like program against the language a little bit because like you're trying to do things that it doesn't want you to do, but like, yeah, I think overall it should be fine. Expression templates. Okay. Yeah, we're not gonna look at that. Yeah, floats are very annoying to work with. Floating point is the source of much evil. Okay, we don't care about this, I think, as much. Polyhedral model, what are we doing? Oh wait, no, this is interesting actually. I remember reading or hearing about this when I was like looking at Polybench specifically. Yeah, interesting. Okay, inline caching, inline expansion. Okay, we could kind of just call this inlining. Yeah, we're having a fun time. Slowly looking through this. I will get to everything as we get there. Small talk. We love small talk. Tiny language. There we go. Yeah, I care less about this. IPO. What is happening here? IPO is kind of its own thing. What are you learning? I'm trying to figure out if we can kind of categorize compiler optimizations, because I thought this would be a fun thing to do for day 200. It is less fun than I thought it would be. It is a bit of a headache, actually. There's so much stuff. Let's see. Yeah, I guess IPO kind of gets its own little category as well. I guess we could kind of put this under like profile guided as well, right? This kind of gets its own little pile. Do you have any of these already implemented? I have just like the very basic constant folding ones done. I also have like SSA construction and destruction, but I'm not sure. Oh, LTO. Yeah, that's actually good. But yeah, I'm not really sure like how much of it is like included in this pile. I guess it is here. Okay, so whole program and then like LTO. Yeah, I guess we could group it like that. Okay, jump threading. What is this? Okay, this is a cool thing. So we just replace this with 100, I think. That's pretty cool. Lazy evaluation. Is program equivalence useful? Yes. It's really important for proving correctness of transformations. So like, what's it called? Alive2, I think, is like the big tool for this. Right now, this is like the state of the art, like, I guess LLVM transform correctness analysis tool. Full blind. So we have like, what was happening here? Okay, this was like an example of a transform. Yeah. Yeah. It's like a really large ongoing area of study, at least. And it's pretty cool. Okay, lazy evaluation, I guess this is like deferred substitution. So we don't really care about this for the most part, I think. Loop interchange, we forgot about this. This is a cool thing. Yeah, something about auto vectorization, that's pretty cool. Okay, loop inversion, what is happening here? I see. So we're inverting the do while, I guess. Right? Or wait. Or we're inverting the condition. Huh? Pipelining. I guess that makes sense. Wow, okay. Sorry. That's cool. Looped nest optimization. Oh man. Strip mine and interchange. What is this? Minecraft? Like, Wow. We got really creative with the names all of a sudden. Okay, that makes sense. Tiling. Okay. This is so broad. Oh, so much stuff. Okay. Reversal. Splitting. Unswitching. Okay, unrolling. What is peeling? I see. So peeling is, I guess, interesting. I guess that kind of fits under unrolling. Wow, okay. That's pretty crazy. Manifest expression. What are we doing? Yeah, I don't care about this. Yeah, sure. Partial evaluation. What is happening here? Oh, as opposed to like lazy evaluation? Sure. That makes sense, I guess. What is this? Partial redundancy elimination. Oh, interesting. Okay. I feel like this is kind of... Okay, this is a form of common sub-expression. I guess that is kind of like grouped under that, huh? Wow. Redundant code, what is this? Okay, that's not helpful. Yeah, we got some... Okay, that makes sense. Let's see. What else is there here? My mom gave me the Life the Compilers guide. Gave me the will to live it. That's crazy. Yeah, hopefully you're doing well. Yeah, it is day 200. I've been staring at like websites for the past 2 hours. I'm like starting to like lose a little bit of sanity here, so we might have to narrow the scope of this stream. I don't have finals. It's like closer to midterm week if anything, but yeah. Okay, this does not help me. Sea of nodes. I remember looking this up at one point. This is interesting. Yeah, it is quarter system. Wow, okay. What else is there here? What is super optimization? Optimal. Okay, sure. That's great. Software pipelining. Wait, what? Oh, interesting. I guess that makes sense. Yeah, so like, I guess this kind of fits under code motion, so I don't really think I want to do too much with it. Oh man. Trace scheduling. Sure. Tree shaking, what are we doing? Unused functions, okay. Live code inclusion. I guess that makes sense. So this is just dead code elimination, okay. That's not an optimization. That's not an optimization. That's not an optimization, but that's a really cool thing that I will present about eventually. Value range analysis. Okay, I think we've exhausted Wikipedia. So if there's anything interesting in LLVM that we've missed, I think it will be good. We need to add SSA. Instruction. Actually, nah. I don't think we need to add that, at least. Okay, arg promotion. Const merge. Dead argilim? Wait. Huh. I guess that falls under like dead code elimination. Man, this is so cool. There's so many different things that kind of fit under one big category. Okay, so we're kind of figuring this out. Deal with issues in symbol generation. If you're talking about my compiler, I kind of already like deduplicate in a sense. If you're talking about like in terms of what I'm looking at here, probably not. Yeah. Oh man, okay. We have inst combine and we have aggressive inst combine. That's crazy. Yeah, okay. Yeah, this is rough. There's so much stuff that happens. Wow. Oh man. I now understand why we can't really categorize everything, because there's a lot to categorize, and that seems a little bit difficult. Memtoreg, my beloved. What? Oh. Code syncing. Wait, what is this? Interesting. I guess that falls under code motion. Wow, okay. So this was pretty exhaustive, actually. It's just everything's like a version of that, I guess. That's really cool. Wow, wait, I'm just thinking about that, actually. That is really cool. I might be more comprehensive with this at some point in the future, but for now I think this is like sufficient for the most part. We should add SCCP somewhere, I think. I remember seeing this in Wikipedia. Sparse conditional constant propagation. Okay, so I think this actually helps a lot, because now we can actually categorize all of like LLVM's passes in this way. What? Dead arg haxer. What are we doing? That's so funny. Okay, tail call elimination I think is interesting. Calls of the current function. I see. We should throw this in here somewhere. Actually, is this like an optimization? Is it really? I guess it is. It's kind of like a its own thing. Yeah, okay. So I think that's a pretty comprehensive list of things we can look at, and now we can try to figure out what the hell we want to do with them. Let's see. So we could probably do like a... Let's start with like compile time evaluation. I think we should rename this as like constexpr. Aside from this, we should also probably put like these into here. And this also goes under like here, I think. This is getting rough. I kind of want to like split up the loop pile actually, because it's kind of like, I don't know, it's very interesting. I guess we can do a redundancy elimination. I guess maybe we could do that. We could kind of put inlining in here in a sense. I don't know if that fits there. Redundancy elimination, we can put like these two in here. Right. I don't know, all of this is evaluated at compile time in a sense. I guess this is like, we could categorize this as like substitution, maybe? And then that means we can also throw inlining in here as well. But like this kind of also like fits under there, I don't know. Yeah, let's actually format it like this instead of Markdown. What's up, Skittles? Yeah, it is day 200, which is also why I'm doing some fun stuff here instead. Okay, so we have inlining, and then we have, I guess, like compile time evaluation. So like this gets tabbed over like that. Loop. We can throw the loop stuff into one pile. Yeah, this is definitely not perfect, but it is gonna be an attempt at least. We have that. We have like redundancy elimination. And then these fit under here. Yeah, it's like that. Found out I'm allowed to use AI on the OOP final? Damn, that's free real estate then. We love that. Yeah, see, this is why I wanted to move the loop stuff into like its own little place. Cause like, I don't know, it like, it just makes a mess, you know? We could do like code motion as its own little group here. Or I guess like, what do we even call it? Right, like loops just make this awful. Dead code elimination gets its own category. Yeah, like I really want to like, ah, we'll put this here as well. I don't know. Grr. We could put auto vectorization under substitution as well. I don't know. We don't really talk about auto parallelization for the most part. That's like a whole category. Okay, and then I guess we have like code gen level optimizations like scheduling, regalloc, and then like people definitely go down there. And then rematerialization also kind of fits under here with like regalloc. We can kind of put this under dead code elimination as well. I guess this gets its own little thing. It's like erasure, we'll call the category. And then we can also throw in like the other two things LLVM does. So like dead argulim, dead story elimination. And then like, yeah, we can do it like that maybe. How does lambda calculus fit into what you're doing? It fits insofar as like you can kind of use it to describe like programming languages. It doesn't really, I'm not really doing a lot with it though. If I were working with like a functional language, it would definitely make a lot more sense. But lambda calculus is like pretty important from a like PL history perspective, but I'm not particularly interested in it, I guess. Yeah, the thing is, right, like, this is rough. Because, like, some of this necessarily just fits in its own category, right? Let's just throw all of the loop stuff into one place for now. And then we will figure out what we want to do with it. Yeah, so let's add a new line there. Let's move CodeGen up here. And then there's more loop stuff. Okay, so then like let's see, so IPO. Yeah, so we can kind of put this here. Yeah, so this like goes beyond the translation unit. So we can do like whole program optimization, link time optimization. All right, take care, Full Primes. Thanks for stopping by. Hopefully you have a good rest of your day. Jump threading we can put in substitution, I think. Redundancy elimination, I guess we can kind of put that there. I think that kind of makes sense. Copy elision, copy propagation kind of fall under here, I think. Right? They definitely fit somewhere here. Maybe under, yeah, maybe under redundancy elimination, actually. Yeah, I guess that makes sense. I guess maybe we could move constant propagation here as well, to be honest. Yeah, so we could do it like, you could order it like this maybe. What was copy elision again? Yeah, okay, so this is a redundancy elimination, I guess we can kind of call it. What is different with copy propagation? Oh, RVO is also here. Wow. Holy hell. Okay, I will definitely expand on this at some point, but I think this is like kind of a reasonable start, at least. Before I go too far. I guess Peugeot doesn't really fall under here. That's kind of its own thing. I guess we could group these under like external info, I guess. And then like, yeah, something like this. And then we just have like this pile here left. And then we have the loop pile. Oh my god, I hate loops. I hate loops so much. Loops are ruining my life. Yeah, actually this probably fits nicely there. And then we can make like a movement category, I guess. I don't know. I guess storage mapping doesn't really... I don't really know what to do with it. I think tail call elimination we can also kind of do with like movement as well, huh? And then we need to figure out what the hell we want to do with these loops. That's the last question. I guess we could kind of jam them under code movement. Right, I guess. I guess it kind of gets its own little pile. This sucks. Okay. It's unrolling that. To do. That's fine. Interchange probably goes like, I would put it like here. Yeah, okay. I think something has gone terribly wrong somewhere, but this seems like a pretty reasonable taxonomy, actually. Yeah, so we can categorize it as such, I guess. Yeah, we'll rename some things. I don't really know what to call code movement, actually. Code motion. Hoisting, sinking. Okay. Motion, I guess? I don't know. Yeah, we can do that. So this includes like code hoisting, code syncing, code factoring. Interesting. Okay. Code factoring. And strength reduction, I guess that kind of goes into like substitution though, I guess. Huh. Or at least the type that I'm thinking of here. It kind of gets its own category, I guess. Okay. And then I guess this is like external optimizations, I guess. Or I guess like, what do we even call this? It's like not really external. Maybe we could do that. I guess we could probably move some of this stuff around. I think this should be like specifically like loop intrinsic. Like this, for instance, I think kind of goes into here, for instance. And then strength reduction, I think this was very specific to loops. I think we can kind of delete it though, honestly. Okay. And then what do we even call this, I guess? Where's this grouped under? It was under IPO. Let's Google IPO versus PGO, and then let's see what compiler is. Does it like try to like make a similarity argument here? Let's see. It does not. Okay. I guess technique wise, I guess? I don't know. We'll just do that, I guess. I don't know. Technique feels really odd. I don't know. Do y'all get what I mean? Like, there should be a word to describe this. I don't know. I'll figure this out off stream. But yeah, I think this is enough shenanigans for one stream. So I will call it here. Thank you all so much for 200 days of this. Let's keep it going. It's gonna be a good time. What's good, JMac? I might be ending stream now. So yeah. Like and sub if you haven't. Join the Discord if you haven't. It's in the description. What else? My GitHub sponsors, GitHub, and my LinkedIn are in the description as well. Yeah, I think that's the whole pile actually. I think there's something I'm forgetting, but oh well, I'll figure it out some other time. Take care, y'all. Take it easy, and I will see you all tomorrow. and we will be back to our regular scheduled content.